Okay, good day everyone. So this video is to help you to recap what you have learned in chapter 1 about the limiting reactant. So this video I will share 3 methods in order to determine the limiting reactant. You can choose either one. So make sure you master at least one method you must know. Because chapter limiting reactant is very important, which questions can ask. Okay, once you determine the limiting reactant, you're able to determine the how much of product that will be formed, or can calculate the mass of the excess reactant after the reactions. So the first step, no matter how, determine the limiting reactants. So method number 1 is like what I have shared during our tutorial class. Okay, by applying the TQC method. Okay, that time, okay, we don't know the format of exam yet, so I share the method which will give you score full marks. Okay, since now the format have changed to objective, so I think we need to strategize it. Okay, so in order to help you to solve the questions in shorter time. Okay, no matter how, I will recap what you have learned. Okay, which will enhance your understanding. Okay, so first write the balance equations. Okay, and balance is a must to balance it, double check. It's very important because it will affect your value regardless which method you apply. Okay, the equations, balance chemical equation is important. Okay, so from the question, this one actually is the tutorial questions I picked from our tutorial questions. It's easier. So the most important thing, the concept must be correct. Okay, first step, okay, whatever they give you the informations, if they give you in terms of mass or in terms of volume, again, not to direct compare in that way. No matter how compare in terms of number of mole, whatever is it in terms of number of mole. So step number 1, we will determine the number of mole for the given. Okay, this one is the given one, right? So it's easier. So this one is solid, they give you in gram. So divide the molar mass by right, you will get 0.0880 mole. Okay, so number of mole for the nitric acid here. Okay, I think something that I need to highlight here is a lot of students, when they calculate the number of mole, they will include this number, the true. No, this one is direct. Whatever given informations, get it from there, because we haven't compared in terms of equations yet. Okay, or apply the TQC method. So direct MV over 1000, because this one is about the liquid. So next, by right, you will get 0.01 mole. From here, if let's say the chemical equation is 1 mole of to 1 mole, then we can directly determine. But now because it's 1 mole and react with 2 mole of this reactant. So this one we are comparing reactants. So previously what we have applied on this part is from the equations, which we can apply the TQC method. From the equations, we know that 1 mole of the copper oxide, okay, copper 2 oxide, will react with 2 mole of nitric acid. Okay, given 0.0880 mole copper 2 oxide, how many more of nitric acid needed? Okay, this is what I have shared with you before. So just to recap what you have learned. So after that, needed 0.176 mole. Okay, then normally we compare with the number of mole for the given one and the number of mole that needed. So from there we are able to determine which one will be the limiting reactant. So given is 0.01 mole and needed one is 0.176 mole. So which value is smaller? Given one, right? Okay, so this from here, if we know that the given compared with the needed one is smaller, meaning that this will be the limiting reactant. So must highlight in your answer, this one is the limiting reactant. Okay, next I will share method 2. Okay, next I will share with you, this one is method 2. This one is based on the definitions of limiting reactants. Okay, as we know that limiting reactant is a reactant that is completely consumed during the reactions, okay, and limits the amount of product. So meaning that limits the amount of product. This method is useful when the question asks you to determine how much of the product is formed. Okay, by right, before you can determine how much of the product is formed, meaning that you need to determine the limiting reactant as well. So this one stone kill two birds. Okay, from there we can determine, let's say, if the question require what is the how much of product is being formed. Let's say this one is the product that we require by the questions. So we can determine by using this method. Okay, first determine the limiting reactant and direct determine the amount of product that will be formed. So meaning that this one also using the TQC method as well, you can apply. So previously we have determined, okay, the number of mole. Okay, so I will write back the number of mole given. Okay, it's easier. The number of mole that given is based on the method number 1. The first step we have done already. So this one is 0.0880 mole, right? And this one is the number of mole of the nitric acid that we have given calculated just now. Okay, so I just want to share with you the method. Okay, so for this, so from equation, so meaning that this one comparing the reactants and the product, which one can produce the lesser, okay, the least amount of product, meaning that one will be the limiting reactant. That is the main idea. So 1 mole of copper 2 oxide will produce 1 mole of this product. Okay, copper 2 nitrate, okay, produce. Okay, so since this one more is easier, so we can direct determine the number of mole of this product produced is 0.0880 mole. Okay, then we compare with the another one reactants. From the equations, 2 mole of nitric acid produce 1 mole of copper 2 nitrate. Okay, so the given number of mole for this nitric acid is mole. Then we want to determine the number of mole that produce. Okay, after you calculate it, then you will get the number of mole for this will be equal to 0.005 mole. So from here, we compare which reactant will produce the least or lesser amount of product. Okay, that will be the limiting reactant. So this is another method. Okay, so this one, if copper 2 oxide, it produces 0.08. Okay, the nitric acid produce 0.05 mole. So meaning that this one is lesser, right? Lesser product that produced. So meaning that this one is the limiting reactant. Okay, let's say the question require determine the mass of copper 2 nitrate obtained from the reactions. Okay, so you can direct using this one and you can get the answer already of 0.05 mole. So you can convert to mass if the question requires in terms of mass. So direct. So this one is 1 stone kill 2 birds. Okay, next I will share method 3, which one is the fastest way to determine the limiting reactant. Okay, so this method direct for 2 reactants. Okay, so this one we call mole ratios. Okay, first you write copper 2 oxide, nitric acid. Okay, just now we have calculated the number of mole. Okay, mole for the given one. Okay, this one is 0.088 mole, right? And this one is 0.01 mole. Okay, based on the given information, we have converted to the number of mole. So this one is the simplest one. So to determine the limiting reactants, so look at the balance equation. So it's very important. Okay, for this 3 method, balance equation is very important to help you to determine. So this one is 1 mole, right? This one is 2 mole. So direct divide 1, you will get 0.088 mole. This one is 2 mole. Divide 2, you will get 0.005 mole. Not more, sorry, this one is ratio. We talk about the ratio, not number of mole. So which one give you smaller value? Very obvious, very direct. where the fastest one. So this one is the limiting reactant. So have you noticed that when I share the three methods will give you the same answer of limiting reactant. So just choose one which will help you. Okay, so thank you for watching. I hope that you're able to master these three methods in order to determine the limiting reactant and choose the one which one is the most suitable to you. Thank you.